Alright, the sine law says that, let me take this, the sine of A over A is equal to the sine of B over B and is equal to the sine of C over C. You might be wondering, when would you ever use an equation that has two equal signs in the equation? Well, technically you would only use two out of these three, so you'd only use either sine A and sine B and sine C, or you can use sine A and sine C. Alright, so when looking at this question that I have on the left hand side of the screen, we see that we have C is equal to 12, so we know C is equal to 12, we know B is equal to 11, and we know the angle C, I'll put an angle, the angle C is equal to 73 degrees. So these are the three things that we know. And what we're trying to find is the angle B. The angle B is what we don't know and what we're trying to find. So right off the bat, we know we're going to have to be using the sine B and sine C. So as the sine A, we don't have an A value right here, and we don't have an A value right here. So let's use the sine of C, which is 73 degrees, and over the other side, which is the side of C, which is 12. Actually, first, what I should do is I should put it as like this. Sine C over C is equal to sine B over B. So, with that being said, what we're trying to do is find the sine of B. We're trying to find the angle B right here. That is what we're trying to find. This is what we're trying to find. We're trying to isolate this. So in order to isolate this, we could, before we substitute anything that we know, what we could do to make our lives easier is get rid of this right here. We could get rid of the B. In order to do that, we'd have to multiply both sides by B. So by doing this, these two cancel out, and you would have B over C times the sine of C. That would equal to the sine of B. So now you have B is a lot easier to solve for now. The reason why it is B over C times sine C is that B is now over the C variable, and it is multiplied by the sine of C, because the sine of B right here is isolated also. So now what we could do here is now we could substitute everything that we know. So the lowercase b right here, we check it is 11, so we have 11. Sorry, my drawing's terrible today. 11, and we have that over C, the side C, which is 12, as you can see right here, 12. And that is going to be multiplied by the sine of C. The sine of C is 73, as the angle C is 73. So let's draw that right here, 73. And that is going to equal to the sine of B. The sine of B. All right. So now, in trigonometry terms, by doing it by hand, you technically hit a brick wall. What should you do now? All right. So first thing you should do is, the way I like to do this is I like to put the sine B, the B on one side, the B on the left hand side, as this is what you are solving for, and you would show that you are using the inverse function of sine. The reason for this is, don't get all scared yet. Why did I just put a sine to the power of -1 randomly? Anytime you have sine to the power of -1, or cosine to the power of -1, or tan to the power of -1, these all represent that they are the inverse function. That is an important word, inverse function. Alright, so let me pull out a calculator right here. So when you go hit function on a normal calculator, or sometimes you would have to press second function and hit sine, cos, or tan. Let's go here, hit function. As you can see right here, there's a lot of complicated stuff right here. There's logarithms. There is a lot more inverse trigonomic ratios and crazy stuff that you've never seen in your life before. Alright, so as you can see right here, these three right here is what I'm trying to focus on. This is the inverse functions of sine, cosine, and tangent. Now, when would you use these? The times that you would use is when you're looking for angles instead of sides. When you're looking for sides, you would just use the normal sine, cosine, or tangent. But when you are looking for the angles, you would use the inverse sine, the inverse cosine, and the inverse tangent. All right. That being said, we know that we're looking for an angle right here, as it's asking you to find the angle B. So now we would know that we would put sine to the power of -1, the inverse sine function, and in this big bracket you would put 11 over 12. Essentially everything that we have right here, 11 over 12 multiplied by the sine of 73 degrees. So now in order to find B, the angle B, what we could do is we could pull out our calculator right here, and let's put everything that we just did. So, the inverse sine function, let's put a big bracket. 11 divided by 12 multiplied by the sine of 73. And that would give you 61.23. 61.24 if you round it. So 61.24. Put the dot on top of your equal sign just right here, just like that, to signify that it is an approximate answer. And when going back to your triangle, you can see that this would make sense because you have one of the angles as a 73 degree angle, and the one that you just solved for is now a 61.24 degree angle. Alright, so this is how you would use the sine law to find an angle. And when you were using the sine law to find a side, it is a lot different, as you aren't paying attention on these. These are invisible to you. These, you cannot see them at all. You're not worrying about inverse functions. Alright. So something you should know before leaving this video is that inverse functions is when you are looking for angles, and normal sine, cosine, tangent is when you're looking for sides. I'll put something on the screen right now to give you an idea, and thank you guys for watching.